In this lesson, we'll be discussing proportional relationships. By the end of the lesson, you should be able to determine if a relationship is proportional or not, and be able to represent a proportional situation graphically with a table and using an equation. So in a proportional relationship, this shows the relationship between two sets of data. It shows a constant rate of change, and it can be shown in tables, graphs, or equations. So here we have this table, and it says that x is increasing by 1 and y is increasing by 50. The graph shows the same thing. If I start at 0, 0, y is increasing by 50 and x by 1. Up another 50, over by 1. Up another 50, right 1. So my slope is 50 over 1, which is 50, so my equation is y equals 50x. The 50 is my change in y over my change in x. So to check for proportionality, we have three ways we can do it. We can look at our ordered pairs and find the ratio of y over x. So we divide each ordered pair, y divided by x, and if we get the same quotient every time, it's proportional. Or we can choose 2 points and cross multiply. If those amounts are equal, it's proportional. If we're looking at a graph and it's a straight line and it goes through the origin, it's proportional. Our equation is always going to be y equals mx, m being the slope. So here in this table, we can look at 72 times 1,419 and 86 times 1,188, and those are exactly the same. Or we can take 1,188 divided by 72 and get 1650, 1,419 divided by 86 and get 1650, or 1,518 divided by 92 and get 1650. So let's do an example. This table shows the number of trees and the number of apples. Is the relationship proportional? So I have three ways of checking. I can see, does it go through the origin? If I take each y and I divide it by the x, do I get the same answer? And if I cross multiply, will they be the same? And in this one, yes. If I work my table and go backward, I would get to 0, 0. If I cross multiply, I get the same answer. Or if I take the y divided by the x, each quotient is the same. So if I want to write the equation y equals mx, I need the slope. I could take the change in y divided by the change in x, which is 26 divided by 2, and it's 13. These quotients will be exactly the same if the relationship is proportional. The table shows the cost of potato salad at the deli. Is this relationship proportional? So remember, I have three ways to check. Is it going to go through the origin? So on my table, would I get to 0, 0? Are my quotients the same? Each y divided by the x. And can I cross multiply and get the same answer? And in this one, yes. If I cross multiply, I get the same answer. If I take the quotients, I get the same answer. And if I go backward in my table, I can get to 0. So my equation is y equals 350x, the change in y over the change in x. Let's look at a few more. So this one, is it proportional? No, it's not proportional, because 1 times 90 is not the same as 5 times 74. So I don't need to check anything else. I can see that it's not proportional. This one, it is proportional. If I cross multiply, 2 times 2.5 is 5, and 1 times 5 is 5. I can also see that each time this is going up by 250, and this is going up by 1. I can also see if I take 250 divided by 1, that's 250. 5 divided by 2 is 250. 750 divided by 3 is 250. I can also see if I go backward, I would get to 0, 0. So for all three of those reasons, this is proportional. All right, this one, not proportional. I can tell already because 3 times 0.65 is not the same as 2 times 0.85. And this one is proportional. 2 times 75 is 150, and 1 times 150 is 150. 75 divided by 1 is 75. 150 divided by 2 is 75. 225 divided by 3 is 75. If I go backward, I can see this is going up by 1. So I go backward and this would be 0. If I go backward 75, it would also be 0. So it is proportional. So how do you set up a proportion? This is to this, that is to that. How can you check for proportionality? You can divide and make sure your quotients are the same, and you can cross multiply.